Welcome to Startalk Radio. I'm your host, astrophysicist Neil deGrasse Tyson. My day job is as director of the Hayden Planetarium here in New York City, which is part of the American Museum of Natural History. And this is Startalk Cosmic Queries. I've got with me Leanne Lord, comedian extraordinaire. Leanne, welcome to Startalk.
Thank you.
Not your first rodeo here.
No, not at all.
Yeah,
not at all.
Yes, I got you just because we got some fun stuff. We solicit questions from our listeners.
Yes.
From many places, from Facebook, from our Twitter stream. You can like us on Facebook, of course, if you find us there, Startalk Radio. Our Twitter stream, Startalk Radio. So that's all we're going to do is explore the universe.
We're just having queries today.
Through the urges of those who listen in. So this is our give back to our listening audience.
Wow.
So just let the record note, Leanne Lord, a professional stand-up comedian, is also a geek.
I am a geek.
Card carrying.
Card carrying, not apologetic at all.
Not even apologetic.
No,
Okay.
not at all.
Just so we know who you're dealing with here. All right. So you got a question here.
I do.
Yeah, let's start right off.
All right. Well, I have a question, Facebook question from Lorraine Shelter. I hope Shetler. I hope I'm pronouncing that correctly, Lorraine. And the question is, do you think private companies are going to be the main pioneers of space tourism and exploration rather than governments? And if so, I love this part. Do you think we'll evolve into the Ferengi? Okay. That's a heck of a jump.
All right. All right. So all these questions actually were they're in a category of space tourism.
Yes, we were talking about space tourism.
Good. So I think there's obviously no reason, there's no point for the government to create a tourist industry. That's not their job.
Okay.
All right. But what the government can do is create the foundation that would allow industries to then conduct that kind of business. So what does that mean?
Yes, that's what my face is saying. Like, what?
So what's a good example of this? All right. So when the railroads cut across the United States back in the 19th century, the United States acquired the land first, okay? Private companies didn't acquire the land. Okay. The United States acquired the land, in some cases fought wars over that, all right? So they acquired the land, found out where the mountains were, the valleys, it got mapped. Lewis and Clark played a big role in this. Once you find out where the friendlies are, the hostiles are, the trade winds are, whatever are the forces that would influence how you might conduct business, the government invests those monies. Then you come later and say, hey, I'm going to pitch tent there because that's safe because the government demonstrated that. The government owns it. It's part of America. So that's an example of the government doing something first. The government was the first to go into space. They, by the way, they tap the creativity of private enterprise to do this. Okay. NASA did not invent everything that got us to the moon. In fact, famously, the LEM, the Lunar Excursion Module, the spider-looking device that landed on the moon softly, that was designed and built at Grumman, Long Island.
Are you serious?
And if you walk Bethpage, the streets of Bethpage, people still beam today over the fact that the LEM was designed in their backyard at the Grumman plant. And so it persists as a cultural point of pride for them. So NASA has always had a relationship with private enterprise. The question is whether private enterprise would lead a step into space rather than government. The government has to do it because for the private enterprise to do something that's expensive, dangerous, and unquantified risks means they can't create a capital market valuation of it. You can't say, oh, who's with me as an investor on this thing we've never done before? We don't know how much it'll cost, but it'll be really expensive for sure, and you might die. It doesn't work.
Not a lot of first responders on that one.
Exactly. Okay. So the government does it first, and the government issues patents. And like I said, the government finds the trade winds and how to do it. Once that's done, it then seeds the pathways to private enterprise and the creativity of entrepreneurs. And so what I see is private enterprise, sure, creating a tourist industry for low Earth orbit. Maybe once we get the pathways figured out to take routine trips to the moon, I'd take a vacation. Would you go to the moon? I go to the moon, check it out. I go to Mars. So you got to be able to do it in a way that's reliable, and then you create the capital market valuation of it. So for business to take an interest in space, the government is going to have to do it first. Otherwise, you'll just simply never get an investor.
So you think there's more work to be done on the government side then, or have those pathways really already been?
No, so the government doesn't need to fund access to low Earth orbit. Low Earth orbit is where the shuttle goes and things like that. So this with SpaceX delivering cargo to the space station, that's a private company doing it. That should have happened decades ago. If you ask me, decades ago. I don't need NASA taking me to low Earth orbit. We've been there, done that. NASA should be advancing a space frontier.
Right. What's next?
People say, I need NASA to monitor Earth with satellites. That's not advancing a space frontier. Get NOAA to do that, the National Oceanographic and Atmospheric Administration, which has the clever pronunciation, NOAA, because it monitors like floods and things like that. Oh, that's how you pronounce NOAA.
Cute.
It's very cute. So, I mean, two other agencies, maybe they can better monitor Earth. But NASA conceived as an agency to advance a frontier, a space frontier. And then you see what's happened behind you to private enterprise. Yeah, go for it.
Okay.
Let that be our future.
And now, are you not touching the Ferengi part of that question? Were you going to ignore that and I just ruined it?
Well, tell me more about the Ferengi. What do you know?
Well, I always thought of the Ferengi as representing that very hyper-capitalist side of human nature. The business at all costs. Will I admit to having the Ferengi rules of acquisition in my possession?
Is that right?
Yes, I will.
Okay. So, but as Americans, we kind of bought into the capitalist dimension of our culture.
Bought in, no pun intended?
No, yes, pun intended.
Okay.
Not all no pun intendeds are not intended.
That's true.
That was very pun intended. So once you accept that, I don't have a problem with going to asteroids and mining natural resources and distributing them around the galaxy. There's still some legal issues. Who owns the asteroid? Who owns the materials? Who brings it back?
Oh, the one with the bigger guns. Come on, Neil.
Excuse me.
Duh.
I'm sorry. I'm just trying to be. So, yeah, that's how the past has done it. But it might be that you don't need guns when the resources are unlimited, as they surely are.
Unlimited resources.
In space. Okay. When we come back to Startalk Radio, more of our cosmic queries here with Leanne Lord, my delightful co-host. We're back with Startalk Radio. I'm Neil deGrasse Tyson, and I'm with my co-host, Leanne Lord.
Hello, everybody.
Leanne spelled Leighann. Lord. I say that because she tweets at Leanne Lord.
I do. Please follow me.
I love your word of the day.
Thank you.
I read it and I'm thinking, wait a minute, is that the real definition or did she just make that up?
Well, I do both. See,
that's messing with me now.
It is. I give a real word, a real definition, and then I give a funny definition.
Oh, okay.
An alternate, as I call it. So.
Right. Well, we'll be the judge of whether it's funny.
That's true. I'm sorry. I just put it out there.
Yeah, there you go. So you're here helping me talk about or comment on whether tourism, what is the future of commercial space, really? And we're in the Cosmic Queries part of Startalk.
My favorite.
Yeah. I think of it as like Startalk After Hours, the Cosmic Queries. And this is our sort of give back to our listeners because they wrote in these questions, and I want to make sure that we give them
I love that you guys do that. I mean, the fact that people are emailing in questions means they're listening and they want more information.
They want more.
That's always great.
To be hungry,
yes.
We feed you. Yes, we feed you these science biscuits.
You actually said something that sort of piqued me.
What's that?
You were talking about this going on in space and, mining asteroids and who owns that and why not go out there? We have unlimited resources. And I'm like, unlimited?
Ooh, that piqued you. Will that work at a bar? Yeah.
No.
Hey, space has unlimited resources.
Hi, here's my number.
Yeah.
What does unlimited mean?
Think about how much of human culture on Earth it turns on an axis of warfare to gain. Let me say that different. Think about how much we invest culturally in gaining access to resources that if we don't gain access, we then fight a war to acquire.
Right.
Okay, and America didn't invent this. This has been going on forever.
We're just good at it.
And it started at the watering hole. Oh, I want the water, and now I'm going to deny you access to that water because it's for me. This is all because the resources are limited.
Right.
We go to places where there's unlimited resources, fruit growing on every tree, and they say, oh, that's a peaceful culture. They don't fight each other because they don't have limited resources. Like, let's get real. We're all human here, all right? Survival is the number one instinct we have.
Right.
Next is reproduction, but survival comes first. And so, basically, you don't want to die.
Right,
and then you want more of you, all right? This is the sequence of how this comes. So in space, asteroids, for an example, have a way of sorting minerals for us. Okay, so why is most of the iron on Earth in the center? Because it's heavier than all the other elements. So it's quite simple that way.
So get in the gym, iron. Work it out.
Yeah, so there's iron on Earth's surface. That's a tiny fraction of the iron that's in Earth. Most of it is in the center. When Earth was molten, if you're heavy, you're going to sink to the bottom. All right? And then if you're a little less heavy than that, you're a little higher up than that. So there are asteroids out there that have been through this process. They're fragments of bodies that once were segmented in this way, that if they were ever molten, the heavy stuff goes to the center. And we have asteroids that are fragments of what was the centers of what were once planets. We call them planetesimals, little planets that formed in the Earth. Isn't that cute? Planetesimals. And so that means it's pre-sorted. So we can get a rock out there that is mostly iron, platinum, gold, silver, iridium, and haul it to Earth. If you get an asteroid like the size of a barn, let's say, and bring it to Earth, it would have more platinum on it than was ever mined in the history of the Earth. So just to give that as an example, that if resources are unlimited, my only hope for peace in space is that if limited resources is the cause of war, of most wars that humans have ever conducted, then unlimited access to resources would render that kind of war obsolete in our future. So space may be the one solution to peace for all mankind.
That was beautiful.
Thank you.
But now there are going to be people that are going to be unhappy about that.
Why?
There are people that make money because things are limited.
Oh, no, sure. But you still have to get the resources, right? Yeah, unlimited, you might think, well, that means there's no value to it.
Oh, no.
But I'm the one hauling in the damn asteroid, all right? And you go get your own asteroid. And I'm going to charge you for this, and you're going to value it by a certain amount. So it has the interesting combination of being unlimited, yet it still requires a provider.
Right, like my cell phone plan. Unlimited, but I still have to pay for it.
Exactly. So what else you got?
All right. I love this. I have a Gene Roddenberry question.
You are the creator of Star Trek.
The creator of Star Trek. And this is from Laylee White Oliver. And she wants to know, Gene Roddenberry believed in science for the sake of the betterment of humanity. As
do I.
As do we all. So say we all on Battlestar Galactica. Do you think space tourism will help or hinder actual space exploration? And do you think capitalism is the best way to make scientific discoveries?
Ooh. So scientific discoveries at their purest have no obvious application to life. That's just how that works.
Okay.
Right? At its purest, it is driven by the curiosity of the unknown.
Okay.
And so there is Michael Faraday in 19th century England who discovers that a wire passing through a magnetic field, he's got a magnet, a little horseshoe magnet, take a wire, pass it through it, and he can measure the fact that the wire gets current induced through it for having passed through the magnetic field. All right, so he has a little, what's called an ammeter, which measures current, all right? So it's kind of cute because it makes the meter tip, all right? And he shows this to friends. And it's kind of quaint. It's like, oh, look what I found. If I move the wire, the dial turns, and it's in the magnet.
That makes him sound like such a boring party guest. Don't ask him about the wire, dude.
Exactly. So you say, of what good could this possibly bring the world, you might ask? And therein is the foundation for how all electricity is produced.
Yeah.
That is the principle of what is functionally a turbine. You rapidly move wires through a magnetic field, inducing a current in the wire, and that creates the electricity that we all take for granted today. And that happened with Faraday and a short segment of wire with an ammeter connected to it and a magnet.
Wow. Big ups.
And at the time, everyone says, all right, is that what I'm paying you to do? Is that what you've done today?
His wife was like, I asked you to take out the garbage, and you out here playing with wires and magnets.
So you can't require the frontier of science to serve the needs of humankind. The serving of the needs of humankind occur later through the mind of clever engineers that say, hey, wait a minute. If you've got that and I can think of, then I create a machine that then serves the betterment of humanity. My physics professor in college was interested in space, and he discovered this phenomenon called nuclear magnetic resonance. He discovered the fact that a strong magnetic field applied to an atom can align the particles in the atom's nucleus. That's kind of cool because then the atom behaves slightly differently if you align it one way versus another.
Okay.
And it's kind of a curiosity. Wait a minute. If you can do that with the atom and different atoms have different signatures and I'm a clever engineer, I'm going to make a new device called the magnetic resonance imager.
Ooh.
The very foundation of what allows us to know what's going on inside the human body without cutting you open is based on a principle of physics discovered by an astrophysicist who didn't know or care what was going on inside your body.
Okay.
So
I'm getting it now.
Are we together on this now?
I'm following you.
So therefore, since you can't require a company to make money off of your invention when it just comes out of the lab, the government has to fund that.
Okay.
Once that's funded, it then becomes out and open and available for engineers to take a look at it who are in the employ of companies who want to exploit it for financial gain. So yes, governments have to fund the frontier of science. Will space tourism allow that? Yes, because if you have a hotel in space and it's at 0G, I might have a 0G experiment I want to conduct. So, but you've got the platform already because you're making money off of it. So I pay you rent, I rent out a room, I bring my experiments, and we're good to go.
Room service at 0G?
The government didn't have to invent a new kind of airplane to buy cargo space on commercial carriers to carry U.S. mail, which is the way people used to communicate. They would write on a piece of paper.
That's for our younger listeners, everybody.
To put it in an envelope. So, yes, once the business goes out there, then science can piggyback those advances. You're listening to Startalk, the Cosmic Queries Hour. And I'm here with Leanne Lord. I'm Neil deGrasse Tyson. We'll be right back. We're back at Startalk Radio, the Cosmic Queries Hour. I'm Neil deGrasse Tyson, and I'm with Leanne Lord. Leanne, you do such noble work in your comedic circles.
Oh, thank you.
You get around not only town, but the country, and you've been in the Middle East working with troops.
I bring laughter to wherever it is needed.
Oh, I like that. So you fill laughter vacuums. That's what that is.
I never thought of it that way.
All right. So I've got you because you're my question reader today.
Yes.
I haven't seen any of these in advance, and you're picking them out for me.
I am.
Go for it. These are from our listeners.
Yes, these are from listeners.
And they've sent in questions. In this case, I think they're all from Facebook, but we also get questions from our website at startalkradio.net. Mm-hmm. And actually, if you like what you hear and you want to pick up archival episodes, you can get it from startalkradio.net. There's like a blog on there and there's fun stuff and you can leave your comments. But if you're sort of more traditional, and you can find every Star Talk there ever was on iTunes.
I love that that's the traditional route. That's where we are now, boys and girls. The technology is moving.
Yeah. If you're old fashioned and you just download iTunes. So what do you got for me?
All right, I have a question from Brandon Miller, and I love this. This is adorable. He said, "How can we have space tourism when most tourists would be puking everywhere?" Very practical questions, sir. We're bringing back the Earth.
Yeah, so all these questions are space tourism based. Yes. So, all right, it is known by many, suspected by the rest, that going into space gives you upset stomach. And one of the primary reasons for that is when you're here on Earth, you're in 1G, all right? We live in 1G. If that 1G changes to any other kind of G, your body reacts. Your ear canals respond. Your brain has to try to reconcile what's going on. And in the effort to do so, you get an upset stomach. Motion sickness, it's called, all right? However, once you have reached the new G in which you're embedded, all right, so the transition from 1G to 0G can give you very queasy stomach. But once you're in 0G, you can just get accustomed to that because the G force is not changing. It's just constant. It's just at a new value, and that new value is 0.
Okay.
So in space tourism, one of the places you might go is orbit. And by the way, when you're in orbit, you're in free fall towards Earth. I don't know if you knew that.
No, I did not.
Yeah. So you say, well, how come it doesn't hit?
So I'm in a bad Tom Cruise movie?
No. So ask, how come it doesn't hit?
How come it doesn't hit?
So how can you fall towards something and never hit it? Because you're going sideways so fast that the very spherical shape of the Earth has curved its surface away from you at the rate you're falling towards it.
Ah.
That's why orbit requires such high speed.
Okay. To keep that
balance. And Isaac Newton figured this out in 1686.
Wow.
He published, the pub date is 1687. He published Principia, the mathematical principles of natural philosophy. That's the full name in Latin. It was published in Latin. And in there, it was the math for knowing this is in there. And he would later publish a work called Newton's System of the World. And in there, he describes the very first orbit. Because watch what happens. If you throw something horizontally, it falls to the ground, right?
Yes.
All right.
I thought it was just me, but I have later learned.
If you throw it faster, it'll go farther away from you before it hits the ground.
Yes.
Right? But it's falling the whole time. Okay?
Yes.
So now let's throw it even faster. And it goes farther along Earth's surface before it hits. Well, there is a speed with which you can throw it so that it goes so far along Earth's surface, the curvature of Earth pulls away from it while it falls towards the Earth. And as it keeps that up, it will stay moving parallel to Earth's surface and make a complete orbit around. And if it makes a complete orbit around, it'll stay in orbit. And that is the definition of orbit. And for Earth, that is 17,000 miles an hour. At that speed, you are moving so fast along Earth's surface, the curvature falls with you. So you're in free fall. When you're in free fall, you are in 0G.
Okay, I've got to be a geek because that is so hot.
That is hot. I just got you hot describing this.
No, I'm really excited because I can see it.
Yes. Okay, so that's why astronauts in orbit are weightless. Because they're in free fall towards Earth. They're just as weightless as you would be if I put you in an elevator and cut the elevator cable. You're in free fall towards Earth.
Okay, I could see that too, and that's not as
exciting. All right. Okay, so the tourist destinations that are in orbit, you'd feel queasy getting there because you'd have to drop from 1G to 0G. But if you stayed long enough in 0G, you just get used to it. Your body says, I'm cool with this. Let's keep it. Now, even so, if you don't like 0G, we'll take it to the moon. That's 1/6 G. Then you feel superhuman because your muscles that accommodate your body weight on Earth are now accommodating 1/6 of that weight on the moon. Oh. You could jump high and run fast and do cool things. Go to Mars, that's 40% of Earth's gravity, right? So if you weigh 100 and give me some poundage here.
20. I'm sorry,
you weigh 20 pounds?
Yeah. No, I was adding to the 100.
Oh, adding to that, right. So if you weigh 100 pounds on Earth, you would weigh 40 pounds on Mars, and you'd weigh 16 pounds on the moon.
Hey, ladies.
Yeah, so pick your spot where you don't get queasy stomach, and you're good to go. You're listening to Startalk Radio, The Cosmic Queries. We'll be right back. We're back on Startalk Radio. This is The Cosmic Queries, part of the hour. And I'm with Leanne Lord. Leanne, always good to look across the table and see you there.
Well, that's good. Somebody wants to see me.
The comedian extraordinaire, and it's great to follow you. I follow you on Twitter, and it's what city is she in now?
Yeah, I know. Where in the world is Leanne Lord?
Where is Leanne? Where the Lord is Leanne Lord? So you're reading me questions, asking me questions culled from the internet, in this case Facebook, on space tourism.
Yes.
Yeah.
And the last question was about people going into space and getting sick, and I just wanted to understand: are you saying people will get queasy like in the transition, but then get used to it? Will they not get sick now at all? I mean, how
interesting? Mild motion sickness. Mm-hmm. Do you know what those symptoms are?
No.
Sleepiness.
Really?
Yes. That's why if you want to get a baby to sleep, you put it in a car seat and drive the car around.
I know people that do that.
Yeah,
I just never knew why.
Yeah, that's why. And if you're in why are you more prone to sleep in a moving vehicle? Have you noticed that?
Yeah, I have.
Yeah. So
knocked out cold.
Yeah, knocked out cold. And so the first sign of motion sickness is sleepiness. Okay? So if the motion sickness is mild, then you just simply go to sleep. So if you're in space and you're transitioning and you're going one location to another, just see if you can park yourself at that first symptom and just sleep through it.
Take a nap, everybody.
Yeah, because if you are in a place where it's 0G and it's fully open and it's pressurized, so you're breathing, and you start throwing up, that's just bad. I mean,
ate something.
Yeah. And then the vomit flies all around. It gets in other people's hair and things. It's not good.
Yeah, it doesn't make a good first impression.
Not good first impression. So it is possible to grow accustomed to that state. But initially, you might want to just take a nap. Or pump yourself with Dramamine on the way. That's what they did with the vomit comet. You know about the vomit comet?
No.
You don't know about the vomit comet?
I don't get out much.
Oh my gosh, you got to get. Well, you do get out, but maybe you're going to the wrong places.
I'm going to the wrong
wrong hovels, right? So there's a company called the Zero G. They might have a new name now, but there's several organizations that have a plane that they charter. You charter this plane. All the seats are taken out, and the walls are padded. And you're in there, you're strapped in until the thing takes off, and it goes in these loops, these parabolic trajectories. So it goes to a very high part of an arc, and then it falls to Earth, okay? And in the fall, remember I said in that previous segment, if you're in free fall, you are weightless. So this goes in a free fall dive towards Earth, and you get about 15, 20, 30 seconds of weightlessness. And it's called, and it got dubbed the vomit comet. But lately, they ask you, "Are you queasy?" Because you'll know because you've been to amusement parks.
Right.
If you know you're at risk, you know. All right. So they pump you with Dramamine. They make sure you don't eat for 6, 8, 12 hours before then.
Okay, I'm out.
So now your stomach has got nothing in it to give, and so now they've reduced the sort of the vomiting factor, and you just have fun.
Wow.
Oh yeah. And what's really cool is if you bring a cat into 0G, because cats always want to right themselves when you let go of them so that they land on their feet.
Oh, you are mean.
But when there is no gravity vector, what does the cat do? Yeah, we got this footage of that. Go Google.
Why are we punishing? We have Schrodinger. How do you say that?
The Schrodinger's cat?
Yeah, we have that cat. We have the Zero Vomit Comet cat. This is bad.
What it means is, deep down, we actually love dogs better. It's because the cats are always the experimental. The cats are the guinea pigs. So you have another question?
I do have another question. Let's see. And I guess, you can answer this one. You should. If
I can't, I will tell you.
This is true. Mark Russell from Facebook wants to know, is a space elevator feasible at our current state of technology?
No. Next question.
Next question.
All right, so space elevator, just for those who didn't know, a big concern in space travel is how do you get to space really cheaply? And it turns out if you orbit higher and higher around the Earth, it takes you longer to complete that orbit. Okay. All right, because you need that right speed to be in orbit. So at low Earth orbit, it's 17,000 miles an hour. As you go higher up, a lower speed will enable you to sustain in orbit. There is a magic distance. It's not magic. There's a special distance at which your orbital speed equals the rotation rate of the Earth. So you will appear to hover over a specific spot of the Earth. It takes you 24 hours to complete an orbit, just the way it takes 24 hours for Earth to rotate. At that distance, you, in principle, could just lower down a cable, and then you climb up the cable and get into Earth orbit. You don't need engines. You don't need launch pads.
Right.
That would be the space elevator. But now the cable has to be strong enough to hold up its own weight. And right now, the carbon nanotubes are the only thing that can do it. And the longest one of those that we've ever made is like a centimeter long, and it's got to be 23,000 miles. The answer is no. We'll be right back. You're listening to Startalk Radio. We are back on Startalk Radio. This is the Cosmic Queries part of our show. Leanne Lord, you're my co-host, my guest co-host for this. Thanks for doing this.
Yeah, glad to be back.
Yeah. So, your previous question was about space elevators. Yeah.
And you said something that, and forgive my ignorance, I wasn't sure I understood. You were talking about that we don't have a cable strong enough to hold up its own weight, far less attaching an elevator to it. So
right, yes, that's why we're not there yet.
Okay.
So a space elevator is essentially parked over Earth's surface at a distance of 23,000 miles from Earth's center.
Right.
And at that distance, it orbits once per day, which means it hovers over the equator at that distance. So you hoist up a cable, you block air traffic from going through there. You don't want to...
Yeah. Hey, guys, go around.
Yeah, go around. We don't want to snare airplanes that go through it. And then, so the cable has to be, first, that long. It has to be able to hold up its own weight, and then you attach an elevator to it, and then have people in the elevator and their overnight bags and whatever else. So it's a really cheap way to get to space, but the technology isn't ready for it. We think carbon nanotubes, which is it's a new form of carbon discovered 10, 15 years ago that is extremely powerful and very light. And when we pioneer that'll transform construction materials, right? One of the greatest challenges of a big building is, can it hold up its own weight? Okay.
I got
This is why historically, bottom walls are thicker than walls at higher floors until steel was invented. But then you need, structures to hold it so the base doesn't buckle out.
Right.
So if you have very light materials, you don't have that problem. So the space elevator would benefit from the same advances that would take place if we pioneer the carbon nanotubes. And it's pure carbon stretched into tubes, and it's way stronger than steel or anything that exists today. So, yeah, there is some hope there.
Okay. Not yet available at Home Depot.
What we really need, not really available, but we really, get rolls of it. What we really need is someone to compose the space elevator music. Because that's a long ride, 23,000 miles.
The space elevator DJ job is now open. How long would that trip take, though?
Yeah,
how fast is that elevator going?
Yeah, I don't know how. I'd want it to be fast, right?
Yeah.
23,000 miles. That's almost as far as the entire circumference of the Earth. So if you're going the speed of an airplane, how long does it take to go around the Earth? It takes how long is that? It takes essentially a day to completely travel around the Earth, all right, in a Mach 1 speed airplane. So, but your view is constantly changing. Earth is getting smaller in the distance.
Right.
And plus you can have entertainment.
Hey,
it's not the act of taking the space elevator itself is part of the vacation.
Okay,
right? You can do that.
Well, yeah, I say that, but people get bored quick. It used to be riding in an airplane was exciting, and now it's passé.
Okay, so you give them a video game, and they're just looking at the video game.
Exactly. So
what else you got? You got other questions?
I do have other questions.
All right.
Let's see here.
In the Cosmic Queries.
Here we go. We go. We have a question from Sheridan McGowan from Facebook. And Sheridan wants to know, where would humans land on Mars if we ever contemplated landing there, and why? It isn't quite space tourism, but it's spacey. But is it spacey?
Well, I think of Mars as the American Southwest. All right, there are places where there's the Grand Canyon.
Yes.
There's beautiful structures that look great in the setting sun. There's a painted desert. There are different terrains that attract different kinds of interests. Mars has the largest volcano in the solar system.
Really?
Olympus Mons, which is Latin for just Mount Olympus.
Right.
All right. And what the tradition over the years had been to name geologic features, in this case Marsologic features, but features on the moon as well, after corresponding features here on Earth. So, for example, there are the Apennine Mountains on the on the moon, and we have Apennine Mountains here on Earth. So there's Mount Olympus in Greece, there's Mount Olympus on Mars.
Got it.
So maybe you're a mountain volcano person, so there'd be a tourist jaunt to there.
Okay.
If you're into valleys and riverbeds, you'd go to Valles Marineris, which is Mariner Valley. And so Mars is not just one destination. It's you can go to floodplains, places where water had once flowed, and you have river deltas. You can go to lake beds that have long ago evaporated, leaving salty residue at its bottom. Salty, what's called precipitate, if you want to be chemical about it. And no different from like Salt Lake in Utah.
Right.
It used to be a liquid lake. The water evaporated, leaving the salt behind. So it's a geologist's dream place. But also, if you're just simply a tourist, it would be stunning. And you can, here, you know what I would look? I would not only look down, I would look up. And I'd take a picture of Earth in the Martian sky.
Ooh, now you're piquing my interest.
Yeah. And Mars actually has 2 moons of its own, Phobos and Deimos. They're kind of lame moons. They're like...
Lame?
Oh, completely lame. Like, one of them is like 8 miles across, and the other is like 15. They're tiny.
You're so elitist.
I'm sorry. A moon should be round. Excuse me. All right. I got, these are like Idaho potatoes shaped and damn near as small. So there's a lot to do, a lot to see, and Mars has cool dust storms too. So yeah, I would go to all those places on 10 different trips.
I'm going to wait till they get a spa.
You've been listening to Startalk Radio. Leanne, thanks for being my guest.
Oh, thank you. Thank you.
Yet another time. Startalk Radio is brought to you in part by a grant from the National Science Foundation. I bid you farewell, and as always, keep looking up.